either a heart or a face card. An or statement says that I'm dealing with a union operation. So I'm looking for the number of hearts added to the number of face cards minus the number that are both hearts and face cards at the same time. How many hearts are there? 13 hearts. How many face cards are there? 12. Are there any hearts that are also face cards? Then you've already counted some of those cards more than once, right? How many have you counted more than once?
3.
The Queen of Hearts, the King of Hearts, and the Jack of Hearts. So you've counted 3 cards as both a face card and a heart. And there aren't 2 Jack of Hearts in your standard deck. If they are, then I'm worried about you playing poker with me. And so on down the line. Now, because there were some cards that were the same, then we deal with removing them. If that had said, what's the problem? How many ways could you get a heart or a spade? Are there any hearts that are spades?
No.
So there would be 0 as an overlap area, as a shared item in the problem. So you don't always have that section, but you always have to check for it. So in this particular case, I would walk away happy with any of 22 cards. 25 from there, but taking away the 3 that were counted more than one time. Any of 22 cards would satisfy my needs. Being able to count becomes an important part of us being able to deal with probability, which is the next topic that we deal with out here. But it doesn't deal with this. So an or statement typically means you're only going to have one event. You're going to do one thing, and you have multiple different ways that you could walk away happy with the problem. So it's an or statement. But we don't always have that. Some of our problems involve the multiplication property of equality. The multiplication property of equality is used when 2 or more events are going to take place in sequence. One happens, and then another happens. An statement tells me I'm dealing with the multiplication principle in a problem. When you deal with multiplication principles, you have to be worried about whether the events are independent or whether they are dependent. Independent events means that the outcome of the first thing has no effect upon the second thing. If I toss a coin and then roll a dice, does a coin have any effect upon what I might get on a dice? Independent events. If I pick 2 cards out of a deck of cards, does the first card have a possible effect upon the second card? Absolutely, because it reduces the number of cards that are in the deck, possibly reduces the number of hearts or spades or clubs or diamonds or face cards or something like that. So those are not independent events. In a multiplication principle, because you have 2 or more events that are going to occur in sequence, you're going to have to figure out how many ways the first event could occur, and you're going to multiply that by how many ways the second event could occur. With that in mind, what that means is that we're going to see problems that might be something like this. Let me insert another blank page. In how many ways may a 4-card hand be dealt that has all hearts? Now, when we're dealing with the multiplication principle for counting, first of all, I have a 4-card hand. So that tells me right away that I'm going to have to get cards from that deck multiple times. So this is the way that I want you to think about systematic counting involving multiplication problems. You have 4 cards in your hand. 1, 2, 3, 4. We're going to play Vanna White and the Wheel of Fortune. 4 cards because there's 4 separate events. And now one very major important question. Does the order make a difference? When you get dealt cards, are you obligated to keep the cards in your hand in the order that they were dealt, or are you free to be able to change them? Can you rearrange them? Which would happen if you're playing gin rummy or poker or 21 or something like that, right? If you're dialing a phone number that has 4 digits to it, are you free to arrange the digits any way that you want? Not if you want to talk to Nana, you're not. So order would be important if it's a unique identifier like a phone number, a zip code, an address, a combination for a lock. But if all I'm worried about is what I'm being dealt out, then I don't care as long as I get all these things, what order they happen to be in. So if your answer to the question is no, then that means that you have a 2-part problem with these 4 lines. Your numerator, because these things are going to look like fractions now, your numerator is going to control the number of items to select from. Your denominator is going to talk about the number of places that that item selected could be positioned. Now your specific requirements are, they must all be hearts. So number 1, total number of hearts. 13, correct? So now, any of 13 cards in any of 4 places. You said I could shuffle them, so it doesn't make a difference what blank I put the 13 on. I'm only going to go left to right because it's easy to be able to set up the multiplication problem out there. But that first card you get would not have to be the first one. It could be in any of 4 places in your hand. The first one, the second one, the third one, the fourth one. Does the first card impact the second card? Well, if you're being dealt the cards, you're not putting them back in the hand, in the card deck, right? So what does that do to the number of hearts? It decreases them. So now the second one is any of, how many available hearts are left now? 12 hearts, right? Because I used one of them. How many spaces are available to put that heart now? 3. Think of chairs around a table. If there are 4 chairs around the table and somebody's already sat in one, when you come up to sit down, are you free to pick any of the 4 chairs? Not really. Although you may want to sit on that person's lap. You may not want to sit on that person's lap too. Okay, so now in any of 3 places. And then the next one's going to turn out to be? How many cards left to pick from? 11. How many places to put it? How many cards to pick from the last one then? How many places to put it? When you do this type of an operation, this will always turn out to be a whole number. But by using the fill-in-the-blank approach to the problem, it allows you to be able to let your calculator do the arithmetic for you in either way that you want to do it. You can multiply fractions, you don't have to do it by hand. You can multiply fractions by multiplying all the tops together, then multiplying all the bottoms together, and then doing the division problem. Or you could actually put into your calculator exactly that, in that order. You could put in 13 divided by 4 times 12 divided by 3 times 11 divided by 2 times 10 divided by 1. It's going to do the multiplication problem for you. You are under no obligation to do something like this, although it could be done. Not too many of you are going to want to do it by hand because you're going to calculate and do the work for you. But there's a 12, and 2 goes into 10 5 times. So if I'm doing the operation,